everyone. This is the fourth video from a series of videos discussing why dawn in Indonesia occurs too early. Please follow the previous videos to understand this video. We are from the Islamic Science Research Network, Hamka Muhammadiyah University in Jakarta. This series of videos is a summary of a book in Indonesian entitled The Evaluation of Dawn in Asia Times. Science, Technology and Sharia Perspectives, which was published on January 5, 2018. English and Arabic editions of the book are being prepared. To order the published book in Indonesian, please contact Hamka Press, phone or WhatsApp, +62 838 7266 8742. The title of this presentation is Use Your Gadget to Detect the Presence of the Dawn. Due to a limited budget, ISRN invites people's participation in collecting the image of dawn in their respective regions. The participation is on a voluntary basis and called the People's Movement in Searching for Dawn, PMFD. We conducted our first program on March 5 to 6, 2017 in Cirebon. As a collaboration with the Muhammadiyah Regional Administrators in Cirebon. It is located some 250 kilometers east of Jakarta or about 3-hour driving. We conducted the data collection at a local port with equipment directed towards the eastern local horizon. We used several sensors, namely, a Fujifilm digital camera operating in video mode with a temporal resolution of 30 frames per second, a sky quality meter, SQM, which was operating with a temporal resolution of 3 seconds. A Lenovo gadget camera operating in still camera mode with a temporal resolution of 6 seconds, and a geometric resolution 640 by 480 pixels to produce a 307,200 pixel image per frame. Unfortunately, when converting the Fujifilm video data into still images in one-day operation, there are more than 26,000 frames. This creates very troublesome data handling, which includes extracting, downloading from and uploading to the Google Drive, let alone analyzing the image. Worse still, the video data turned out to be damaged due to overheating. The SQM data analysis for March 5, 2018. On March 5, 2018, we started the SQM data collection at 4 hours 8 minutes and 26 seconds or 25 minutes before the official dawn at 4:33 a.m. Until 5 hours 23 minutes and 18 seconds a.m. or about 27 minutes before the sunrise at 5 hours 50 minutes and 42 seconds. With the 3-second temporal resolution, we have 1,486 SQM data. However, to determine the exact occurrence of the real dawn, we only need to process the SQM data in a limited window between 4 hours 55 minutes and 0 seconds a.m. and 5 hours 23 minutes and 18 seconds a.m. We applied 3 polynomial models, the third, the fourth, and the fifth, and took the weighted average value for the dip calculation. Graphically, the polynomial model is shown in this slide. The x-axis shows the timing, whilst the y-axis shows the sky brightness data, measured in MPSAS or magnitude per arc square second. This blue solid line represents the physical data of the SQM recording, whilst the red dotted line is the polynomial model of the SQM data. The graph shows an almost perfect match between the recorded sky brightness data with the polynomial model, which gives the root mean square error of 0.2 magnitudes. From the algorithm explained in our first video entitled Why is Dawn in Indonesia Too Early? 1. We estimate the real dawn occurred at 5 hours 8 minutes and 18 seconds because beyond this point, the SQM data continues to decline, which proves that the sky was getting brighter due to the presence of the reflected sunlight by the atmosphere. It simply means that the dawn was first detected when the sun was at -11.2 degrees below the local horizon. Meanwhile, the government's official dawn at -20 degree dip should have occurred at 4:33 a.m. as shown by this arrow. Some 22 minutes before this line because it shows the timeline at 4:55. The verification process using a Lenovo gadget camera edge detection technique to assure the reliability of the dip estimation using the SQM data. An independent verification process using other sensor is required. As Fujifilm images are damaged, we use the Lenovo images to verify the presence of DON detected by the SQM sensor. First, we applied the edge detection technique for Lenovo images taken at 4 hours 31 minutes and 54 seconds AM, or about a minute before the official DON at 4:33 on the left, and the image taken at 4 hours 38 minutes and 24 seconds, or about 30 minutes before the SQM's DON at 5:08. We cannot distinguish the difference between these two figures, which further tells us that it is impossible that the DON occurred between 4 hours 31 minutes and 54 seconds and 4 hours 38 minutes and 24 seconds AM. Similarly, when we compare the detected edge of the image taken at 4 hours 31 minutes and 54 seconds on the left and the image that was taken at 5 hours 0 minutes and 24 seconds, or 8 minutes before the SQM's DON, again, we cannot differentiate the delineated details of the two images. Therefore, it is impossible that the DON occurred between these two timelines. Finally, the occurrence of the DON is distinguishable when we compare the image taken at 4 hours 31 minutes and 54 seconds on the left and image taken at 5 hours 9 minutes and 18 seconds, or exactly a minute after the SQM's DON. Delineated spots in this central part of the right figure are representing the reflected sunlight by the atmosphere, although the sun was still located some -11.2 degrees below the horizon. Image adjustment technique. In the second verification process, we used the same images. First, we compared the image adjustment of the image taken at 4 hours 31 minutes and 54 seconds on the left, and the image at 4 hours 38 minutes and 24 seconds on the right. No difference detected between these two figures, which simply verifies it is impossible that the DON occurred between these two images. Likewise, when we compare the adjusted image taken at 4 hours 31 minutes and 54 seconds, or about a minute before the official DON, and the adjusted image which was taken at 5 hours 0 minutes and 25 seconds, or 8 minutes before the SQM's DON, again, no difference detected between these two figures, which simply verifies it is impossible that the DON occurred between these two timelines. The difference is obvious when we compare the adjusted image taken at 4 hours 31 minutes and 54 seconds on the left and at 5 hours 9 minutes and 18 seconds, or just a minute after the SQM's DON. The spot in the central part of the right figure is a representation of reflected sunlight by the atmosphere. However, when we look at the original image, the image that was taken at 5 hours 9 minutes and 18 seconds is still dominated by black pixels. It simply proves that the naked eyes would not be capable of detecting the presence of DON. The SQM data analysis for March 6, 2018. On March 6, 2018, we started collecting the astronomical data from 3 hours 41 minutes and 23 seconds, or 53 minutes before the official DON, at 4 hours 33 minutes and 13 seconds. It ended at 5 hours 55 minutes and 27 seconds, or 5 minutes after the sunrise. The SQM data analysis for March 6, 2018. Using the fourth degree polynomial, the estimated DON appeared at 4 hours 55 minutes and 57 seconds, or at the dip of -14.4 degrees below the local horizon, as indicated by the blue line. Meanwhile, the official DON should have occurred at 4:33. Please note that even at 4 hours 37 minutes and 0 seconds, the sky is still completely dark. No indication of the presence of the DON. Edge detection technique. Similar to what we have done for image analysis for the image taken on March 5, 2018, we began to compare the image taken at 4 hours 31 minutes and 54 seconds as a benchmark on the left, and the image taken at 4 hours 38 minutes and 30 seconds, or 5 minutes after the official DON on the right. no difference between two figures, which clarifies it is impossible that the dawn occurred between these two images. When we compare image detection of the benchmark image at 4 hours 31 minutes and 54 seconds on the left and the image that was taken at 4 hours 58 minutes and 0 seconds or 2 minutes after the SQM's dawn, the difference began to be distinguishable. Look at these delineated spots on the figure on the right. Comparing the image adjustment of the image taken at 4 hours 31 minutes and 54 seconds on the left and image taken at 4 hours 38 minutes and 30 seconds on the right also further confirms that there is no indication that the dawn had appeared between these two images. The presence of the real dawn becomes apparent when we compare the image taken at 4 hours 31 minutes and 54 seconds on the left and image taken at 4 hours 58 minutes and 0 seconds on the right. This confirms the presence of the SQM's dawn at 4 hours 55 minutes and 57 seconds. The presence of the real dawn is more apparent in the next images at 5 hours 5 minutes and 0 seconds and 5 hours 15 minutes and 0 seconds or 17 minutes after the SQM's dawn at 4 hours 55 minutes and 57 seconds. However, our naked eyes are not able to differentiate the presence of dawn from the real image taken at 5 hours 15 minutes and 0 seconds. Conclusion: there is no scientific evidence that the dawn had appeared at -20° dip. Subject to further investigation, a gadget camera seemed to be sufficiently good to verify the presence of the dawn detected by an SQM. The main instrument for the detection of the real dawn will remain to be an SQM. It is versatile, reliable, and relatively low cost. It costs only around $350. Training is needed for processing the SQM data and camera gadget image data. God willing, ISRN will provide training to those who are interested. So far, ISRN has demonstrated the use of 4 different sensors to detect the presence of the real dawn. The main objective in applying different sensors was to prove that the dip of -20° that we have been practicing so far is correct. Unfortunately, scientific facts tell otherwise. Statistically, the dawn occurs at the dip of -13.3° as demonstrated in our first video. The current dawn is therefore about 26 minutes too early. Thanks for watching.